Hello students, Algebra 1 is here, lesson 74, and we're going to begin working on a very important topic. This is a topic that you will see again and again in your math classes. It's also a topic that comes up again as a calculation in physics and chemistry classes. One of the strengths of this Saxon curriculum is that it prepares you for math-based science classes really well, and this lesson is crucial in getting you ready for some science classes. What we're going to learn is a process of rewriting numbers that's called scientific notation. The reason this is important is in science, specifically chemistry and physics, as I mentioned, you can have numbers that are either really big, like the distance to stars, or very small, like the weight of atoms. So we need a way to write those numbers that is a little bit simpler, that makes it easier to calculate with them than having a whole bunch of zeros. So let's just dive into an example, 74.1, and show you how this works. The example, I'm on page 303. It says to write this very small number in scientific notation. I will write it down for you. It's 0.000316. It's a big challenge for me to see these zeros in the book with my eyes still being challenged at short distances. So, this is the number we have. We want to write this in scientific notation. Here are our steps. The first thing that we do is we move the decimal place immediately after, I'm not going to write immediately because it's too large. Move the decimal place after the first non-zero digit. That sounds weird. Let me tell you what it means. We look at our number, we see a bunch of zeros on the front end. We see some actual non-zero digits back here. We want to move the decimal place to be after the first non-zero digit. The first non-zero digit is 3, so we want to move it to be right there. Okay? So that's step 1. Look at this. I'm way down here already. Count the jumps. Okay, that's my non-mathematical shorthand for saying we want to count how many jumps we made, and I always draw it out. 1, 2, 3, 4 jumps to get it there. Now we rewrite the number like this. We take the part that is now we take the non-zero digits, 3.16, with the decimal place where we want it to be, and we multiply it by 10 to the 4th power because we made 4 jumps, okay? So we write, and now we decide, can you still see? Kind of. Plus or minus. Okay, this is the hardest part of scientific notation. Figuring out where to put the decimal place is fairly easy. Counting the jumps from the old place to the new place is fairly easy. This is the hard part. We need to decide whether this is a negative or a positive exponent. And the way different math teachers teach this in different ways, and frankly, I think a lot of teachers do a really bad job of it. So no matter what other teachers tell you in the future, I encourage you to focus on this approach. We look at the number as we've written it in scientific notation. We look at the actual digits themselves, and we say, once we convert this from the form we have it here back to its original form, are we going to be making the number bigger or smaller? That's the question we ask ourselves. As we convert back to the original number, is our scientific notation number going to get bigger or smaller? If it's going to get bigger, then we would use a positive decimal. But in this case, our number is actually going to get smaller, right? 0.000316 is much smaller than 3.16. So our number, as we convert it back to its original form, we're going to make it smaller. So we need to use a negative sign here, okay? And then that will tell us, if you see it in this form, what you'll see is that this minus sign tells you to move the decimal like so 4 times and then fill in with the zeros, all right? We'll work on those conversions as well. For now, we're practicing these steps. Let me do one more for you. I'll do 74.2. And it is, oh, okay, this one's trickier, 0.000316 times 10 to the minus 7. Oh, that's really bumpy, but I bet you can see it. So now what we're doing is we're taking a number that's not in scientific notation, and we're multiplying it by a power of 10 with a funky decimal on it. This one we do in 2 steps. Okay, these are our original steps. You know what? Actually, I'm going to flip to a fresh page because I don't want to confuse you. Okay, so let me rewrite 74.2. It's 0.000316 times 10 to the minus 7. Okay, then what we do, so we have 2 steps here. First, we write the number in scientific notation. Okay, so first we just look at this part of it. That's the number. We want to write that in scientific notation. Now, as you'll notice, we just did this. This is the exact same problem that we just did. 1, 2, 3, 4 jumps to get that decimal place where we want it. So we know it's 3.16 times 10. 4 jumps, we decide plus or minus. We want this number to get smaller as we convert it back to its true form. So we know we want a minus sign there. And then, so now we've converted that. Now we use the product rule to combine the exponents. And I'll show you what I mean by that. These things always sound weird. So now what we've done is we've converted this number to scientific notation, but we still have this part, don't we, to consider. We have to flow that into our number. So here's the way we do it. 3.16 stays the same, but now we use the product rule, which says that when we're multiplying 2 numbers with the same base and different exponents, we add the exponents, right? We've been doing that for a long time. So this becomes 10 to the minus 11. All right? So that is your final answer. Okay, I want you guys to go ahead and do examples 74.3 and example 74.4. Example 74.4 has multiple parts, and if you go in order, you'll see that they build on each other just as we did in this example. Go ahead and give those a shot, and good luck with this.